Okay, this one should be shorter. Okay, so now draw lines. So we're looking at composite shapes or composite figures. So all this is that you can break the figure up into smaller recognizable shapes so that you can calculate surface area or volume or whatever it's asking for based on those shapes, okay? So here it says draw lines to divide the composite figures into two or more component composite shapes. I can't talk right now. Now, the way I divide things might be different than the way you divide things, okay? It doesn't matter as long as you're dividing it in a way that it's a recognizable shape that you can actually calculate stuff based on, okay? So first things first here, I'm going to draw a line here, and I would have a triangle and a rectangle, right? Okay, this one, again, you could do it two ways, right? I could do here, and I could have a rectangle, or I could do here and have two rectangles. I'm always going to have two rectangles. It just depends on how I'm drawing. Okay? Here, I'd have a triangle and a rectangle. Okay, here, think of it like a track. So you come across here, and you come across here, and now you have a rectangle and an entire circle. Because if you pulled that rectangle out and put the two pieces together, you'd have a circle. Okay, here, it's a little more different. If I cut it in half, I have two parallelograms. Two parallelograms. And then this one is always, everyone always argues, I don't know. 3 rectangles, you can do the lines across the top. Again, it doesn't matter as long as they're recognized shapes. It does not matter as long as they're recognized shapes. Okay. So, draw a line to divide each shape into composite shapes. Then find the total area of each shape. Okay? So, how do you want to divide this up? I would argue right away that I'm going to divide it this way, because first of all, when I'm looking at this, I know it's 12 by 3 right away. And then here, I know that this is 5. I know the entire thing is 7, but we know that this is 3. So then this part would be 4. Okay, so I would divide it up that way because I personally think it's easier. What I like to do, just to make things look easy, is I'm going to enable this one and this too. And I'm actually going to do rectangle 1 equals length times width, which is 12 times 3, which is 36 millimeters. And then rectangle 2 is length times width, which is 4 times 5. Oh, for some reason. So 20 millimeters. And then I go, because I'm looking for total area, right? Total area equals rectangle 1 plus rectangle 2 equals 36 plus 20 equals 56 millimeters. Okay? You do not have to do that. It's up to you. It's up to you how you want to show the work, okay? Again, the more, especially on these ones, because there's so many like little components that if you only give me the end number and you get it wrong, I have to give you 0. If you even wrote down equations, so I know that you recognize the shapes and what you're doing, I can at least give part marks for it. Okay? Okay, next I'm going to put a line here, and I'm going to recognize that I now have a triangle and a rectangle, okay? The base of my triangle is 6, the height of my triangle is 8, or 4, excuse me, because the whole thing is 8, and I know the side of that rectangle is 4, so what's left over is another 4. Okay, so what I do here is, area of the triangle is equal to base times height divided by 2. So in this case, it's 6 times 4 divided by 2, which is 24 divided by 2, which is 12 centimeters. Okay? Area of the rectangle. You can write areas of the rectangle, you can draw pictures, I don't care, just so I know which one is which, okay? Where you're doing which calculation is length times width. Of course, you would never write left to right like this. The only reason I'm doing it is because I had no space. So it's 4 times 6, which is 24 centimeters. Okay. And then total area is area of the triangle plus area of the rectangle, which is 12 plus 24. And of course yours would be way neater than mine is, but I have no space. 36 centimeters. Oh, sorry, you guys are telling me squared area. I dropped my squared. All units, when I'm calculating area, are squared.
I did it to find the hypotenuse.
You actually don't need to because you've given your base and height of that triangle because it's a right angle triangle. Right?
But you have to add the 3 to get the area of the whole triangle.
Add the 3? No, that's calculating perimeter.
Oh, okay.
Yeah, no, just base times height, because that's a calculation. So the base of that triangle is 6, the height of that triangle is 4, so I actually don't need the hypotenuse for that, because I have enough information to calculate. Right? Okay, next, we can just verbally discuss this, especially because it's going up on the website, so it's not a big deal. Discuss how to calculate the total area of each shape above using net area. Okay, does anyone know what a net is? Can you think of what a net is? So a net is, if you were to sort of flatten the image out, what the net looks like, okay? Oh, sorry, no, I'm backwards. This is an opposite thing. Net area is when you like draw a big rectangle around it, or a circle around it, or something, and then you subtract the area. So for example here, net area would be if I did this to finish that rectangle, okay? I could calculate the rectangle, that whole rectangle. Do you guys agree? And then I could calculate that triangle and subtract it out, and I'd get the value. Okay? So what it would be in this case is it would be total area is equal to area of the rectangle minus area of the triangle. And when I'm talking about the rectangle, I'm talking about this big rectangle here. Okay? So it's like you calculate the area of a bigger object and then subtract things away. Prime example of this is they draw a tire or a circle or a donut or something, right? And they want to know the area of it, but we know a tire and a donut doesn't have a center. Does everyone agree? So what you do is you calculate the area of the whole circle and then the area of the little circle, and you subtract the little circle out of the big circle. So that's what they're talking about here. I got ahead of myself thinking about the other net part. Okay, good? Okay, so this is an example. Determine the net area of this shape. So the shape is actually the gray part. So, you know, think back to the Flintstones when they would make like square wheels, right, as a joke. Is the Flintstones? Okay, whatever. Okay, so what you're going to do is you're going to calculate the area. You guys don't know what the Flintstones is?
I'm sorry.
Okay, now we're done. You like all did this week. Anyway, so you calculate the bigger area of the whole square or rectangle, and then the center, and then you subtract them. Okay? So I have area of, I'm going to call that square 1, and I'll call that square for rectangle 1, rectangle 2. Okay? So rectangle 1 is length times width. So length times width is 8 times 8. Everyone knows that these dashes mean that they're the same length, right? And the double dashes means everything with a double dash, in this case, is 3. So this is a square. So 64 inches squared. Okay? Area of rectangle, or now we know it to be a square 2, is length times width. which is 3 times 3, which is 9. Now, because we're doing the net area, you're going to go total area is equal to area of rectangle 1 minus area of rectangle 2. So I get 64 minus 9. I can't do basic math in a minute. Okay, I was right. I second guessed myself. Inches, and remember area, so inches squared. I'll put my units here. Inches squared. Okay. Does everyone have this down? Okay. Determine the total area of the garden below to the nearest